Music. Hello friends, my name is Amit. Welcome to the NDT Quality YouTube channel. So friends, in today's video, we are going to see DB related calculations in ultrasonic testing, and in this, we will specifically see how the DB ratio works. Then you will have an idea that as soon as you get any echo on your screen, if you increase the dB in it, then its height will increase, and if you decrease the dB, then the height will decrease. What is the logic behind this, and how do you increase or decrease the dB in the screen? Then in what way? That is, in which ratio? Does the height of this echo go down or up? In this, if you give a UT level 2 or level 3 exam, you definitely get at least one question related to it. That is, you are asked at least one question related to this logic. And like there are level 3 exams like level 3 etc., then the problem in that is that the time we have a little less. So if you know the ratio, etc., then you can get the answer directly without doing any lengthy calculations. You will get the answer directly. I will also tell you how the ratio is taken and how to calculate it. You will also get an idea of the logic behind this BB, i.e. gain, in this video. If you have not yet subscribed to our channel, share this video with your friends and colleagues. Apart from this, you can get membership of the channel by using the join feature. So, I've made many videos for Member XG, in which you will get the complete syllabus of NBT Level 2, in which we have covered the syllabus of RT, UT, MT, PT in detail. Apart from this, I have also made many videos on code standard interpretation. We have discussed the NDT-related acceptance criteria and procedures of API, SMET, apart from AWS code. You'll also find plenty of practical NDT videos on the channel. You can use the join feature to access these videos and support me financially. So, here we'll see in detail how the BB ratio works, and how the echo height is calculated based on it. So, the decimal BB ratio is a logarithmic unit. Right, first of all, it's a logarithmic unit. So, whenever you want to calculate it, you should know how to use log or antilog in a calculator. So, generally, if there's a UT level 2 or level 3 exam, you're given a calculator, or if it's an online exam calculator. So, you should know how to use a logarithmic chart or logarithmic unit. So, we'll discuss what log is later. How does log antilog work? So, the dB ratio is a logarithmic unit express the ratio of two values of physical quantities of power and intensity. So, this is a physical quantity. So, sometimes there are so many units you can't show them in a single chart. Their quantity is very high. So, for that, we use logarithmic units for echo height calculations. Means they will become we short. Also use ratios. So, we use the ratio of two physical quantities in logarithmic units. In the context of ultrasonic testing, dB is used to compare echo heights, which are proportional to the amplifier's output voltage. So, what dB actually is, it's proportional to the output and input voltages. If the output is higher, you'll get a higher echo height. This means that as you increase dB, the voltage will increase. So, it's directly proportional to the voltage. We'll explore how dB ratios can be used to calculate echo heights and how gain adjustment works. Affect this measurement. So in this we will see how you have to calculate echo height, etc., and gain adjustment means how to make dB up or down. So how does the height of echo go up or down by this? So it is very important to understand its ratio. You must be knowing the basic dB calculation here. We have discussed this in many previous videos, and recently I had made a couple of videos in detail in which I had explained the basic calculation. So in this I will tell you from the top. The formula to calculate the dB difference between two echo heights A2 and A1 is given by, so there are two amplitudes. The height of two echoes is A2 and A1. So to calculate this, This formula is dB equals 20 log A2 slash A1 and the base of log is given as 10 here. See, this is correct. Base 10 is given. The base is any mathematical calculation, and that the base can be 10 or it can also be based by E, right? But in our case, remember that the base here is 10 and A2 and A1 are the height of two echoes. So, suppose you see two echoes on the screen, right? Not two, but the same echo. Suppose the height of the first echo was a 1 and later the height of that same echo, you increased the dB and it became A2, right? You can use this formula to know the dB difference of the height of the first echo and the height of the second echo. Meaning if you increase this much dB, then you will get the height of this echo in A2, right? So, suppose the height of a 1 is 30 and the height of a 2 is 60, then you will directly add 60 in A2 here. If you put 30 in A1, you will get the answer in it and log is there. We'll directly do the calculation in the calculator. So the value of log will be 2 slash 1. In this case, you will get 2. If you do log 2, you will get this answer. If you convert it to the value of dB, in this case, you will get the answer approximately 6 dB. So if we increase it by 6 dB, then the height of the echo doubles, right? Is a very general theory. You will have an idea. If the echo is 30%, if you want to make it 60%, then you have to add plus 6 dB. If it was 60% earlier and later you have to make it 30%, then you will have to add minus 60 also. Okay, how this calculation works, it is very easy. If we talk about the example, then you will not get such a straightforward example in any exam. They ask in a little twisted way. So see, the first one is calculate dB difference between two heights. So like the first example, what is the dB difference between 20% full screen height, 80% full screen height echo? So two echoes are given. You have to find their dB difference. One is 20% full screen height and the other is 80% FSH. Height is meaning a full screen. So in comparison to full screen height, one is 20% and this one is 80%. Simply two amplitudes are given here. You have to assume this is A1 and this is A2. So, if you want to write this above, A1 below, then you will have to take log 4 in it, write LG20. Log 4, you will get it like this, so if you calculate it, you will get the final answer as 12. So what does it mean that you have to multiply the height of the echo by 4 times? Later, if you want to make it 80%, then you will have to increase it by 4. Sorry, 12 dB. Right, if you want to increase the height of the echo by 4 times, then you will have to increase it by 12 dB. Similarly, the second one example is to increase 10% echo to 100%. What is the increase in a dB needed? So what to do here is that earlier the height of echo A1 was 10% and A2 100%. Okay, so the height of echo has to be increased 10 times for this. If you do calculation, then you will get 20. Answer you increase 20 by 20 degrees, then what will be the height of echo? It will become 10 times more. Similarly, if you decrease by 20 degrees, then it will be minus right, means it will decrease 10 times, so it will be 200%. Suppose then it will become 20% if you do 20 dB. So similarly, see example 3 to decrease in 80% echo to 40% echo. What is the decrease in 8 dB needed? So what to do here is to decrease the echo, so you will get the value of dB in minus. Okay, but fully you have to use the same, but you will get the automatic answer in minus. So for this you have to take a 180%, which means earlier the height of the echo, and later you want a 2, which means 40% height of the echo. So how many dB you will have to subtract? If you put the value in it, then the lower side will still be 80 and the upper side will be 40. So in this case, you will get an answer like minus 6 dB. Okay, so this is how it works. This is a very easy example. However, if I talk to you about a little more difficult example, then many people face problem in calculating the echo ratio, and this you have to take anti-log, right? The calculation we did here, you had to take log directly here. You have the option of log directly available. All the calculators also have antig, but people face problem in how antig works, and sometimes even while searching in the calculator in LC. Then how antig works, you should know that it does this. Like if there is anything, you have to take its antilog. So it is said 10 over 10, like this, right? So suppose you have to take the antilog of 4. Okay, antilog of 4 angle 4. Suppose you have to take it like this. Then its meaning, you have to answer it. So You will have to do it like 10-4, right? Similarly, if you have to do analog 2, suppose what will you get? Then you will have to do it like this, okay? Analog works like this. So why do you have to take only 10 here? I have to take 10 for this because the base of our log was 10. I told you that earlier. Also told, right? So keep this in mind. Where did this equation written here come from? Our first equation was like this equals 20. Algae A2/A1. This was like this. Okay, so now in this calculation itself, its base here is 10. Okay, so we have changed only this. Nothing else has been done. So see how it was done. It became dB/20. Here 20 has come down equals Lg here base 10 is A2/A1. So now we have to find the echo ratio here. Echo ratio means what A2/A1 is. So for this I will have to find the log. This log 10 which is written. We will have to find the base. So to find the log, we will have to take the analog of this value in front. Right. So the log will go in front. So it will become the analog of the value in front. Okay, so simple. If you calculate it further and simplify it, then A2/A1 equals log of BB/20. This is how you will get it. Okay. So this is the same formula as given here. So you can remember this formula also. It is like the reverse question has been asked. Till now in the calculation that we saw, the height of echo was given that it is 20%, 30%, later 60% has to be done. The height of both the echoes was given. Now how will the calculation come in which dB would have been given? Okay, dB would have been given that if you increase dB by this much, then how much will the height of echo increase? Would have been asked. That means in that case you can use this equation. So to calculate echo ratio, you will have to use this equation. Okay, so this is also quite easy. If you know how to take antilog, then it will become easy. So see its example. Effective gain increase on echo when gain is increased by 12 degrees. What will happen to 30% echo? Okay, so first assume that the height of echo was 30% and later you increased it by 12 degrees. B if it is increased. So in that case, the second echo means the same echo, but how much? Will the height of that echo increase? That means which amplitude will be obtained. So what will have to be done here? The value of BB in this is 12. So what will happen here? I will do the calculation here and show you. You will get an idea. Okay. Actually here I have it is written directly. So A2/A1 equals M log 12/20 is written right here. It is 12/20. So I will write it directly here. If you do 12/20, you will get 6 in the calculator, 0.6. So you have to take the antilog so as I just told you what is antilog. You have to take it by multiplying it by 10. So what is antilog 6 equal to? 10.6. You will have to take this value. If you do this in the calculator, you will get this answer, 3.98, means you got almost this 4 answer. Okay, so this 2/A1 means 4. So its meaning in simple can be said language that if you increase it by 12 degrees, then the height of the echo will become 4 times. Okay, the ratio of amplitude, you will get 4 times. So it is given that the height of the first echo was 30%. So later, if you do 4*30, then how much will you get for the second echo? 120% means the value of 1 is already given, right? What value did we get? A2/A1 equals 4. So the value of a 1 is already given. So A2 equals 4*30%, right? The value of a 1 is given as 30%. So the value of a 2 means the value will be 120%. Okay, so this is how your calculation is done. In this, the reverse is asked. That is, dB is given and later you have to find the height of the second echo. Second example, when gain is decreased by 6 dB, what will happen to 30% echo? So here the gain has decreased by 6 dB. It has decreased. So will you get in that case? In this case, you will have to take the value of dB and 6 is written as analog minus 6/20. So when the word decrease is written, you will have to take the minus. So if you do minus 6/20, the answer will be minus 0.3. So you will have to take the analog of minus 0.3. So if you take its analog, the answer will be 0.50. So this is the answer given. Whatever calculation I do here, so I am doing it in that. Suppose you also have a calculator doing it, so key, then you will get an idea. Okay, so A2/A1 is 5, which means it will be halved. The echo will be halved. So here the height of echo was 30 degrees before and after it was minus 6 degrees. The answer got is 5, 13 to 5. This is very general. 15%. We know that if it goes then 6 dB, then the height of the echo becomes half. Okay. But different values are given in the supposed exam like 4 dB or 3 dB or 2 dB, 8 dB, 10 dB, 12 or 14 dB. So in this way different values are given. That means odd dB are given. So what to do in that case? I will also tell you this in the end. Ratio is just that. If you remember it, then it will be very easy to find the echo height. So field. How is this used in work? I just told you the entire calculation of echo height in the end. How will it be used in field work? So in field work, officially needed when the echo height exceeds 100%. If the echo height is 100%, then it means it will be more than 100%. Then you can use this dB calculation in that case. It is very easy, and sometimes it happens that if it is more than 100%, then you will not. Currently, the echo height option is also available in the machines that have come. So if take the gate, then if you take the gate above whatever echo is above it, then it also shows the echo height percentage. But this option was not available in the old machine. So in that case, the echo is more than 100%, then the echo height percentage will not be visible. In that case, use this calculation. In such cases, game is reducing step until the echo tip is visible on CR tip, so you have to slowly bring down the dB to you. See the tip of the echo. From the reduction in dB, the actual echo height can be calculated. So how much dB did you decrease? How much dB did you reduce? On that basis, you will get the height of the echo. You will get the actual height of the echo. Give you an example. Suppose the echo's natural defect was greater than 100%. Right, means it was more than 100%. But how much more it was, I don't know. 200, 300, 400. It was, what percentage? I don't know. When the gain was reduced by 8 dB, means you reduced 8 dB. The echo height became 95%. The height of the echo became 95%. Calculate the original echo height. You have to know what was the original echo height. Okay, here you are given two values. The value of a 2 is given. Okay, means you have to find out what was the height of the echo I did not know that. This is yours and you have made it minus 8 dB. The value of dB is minus 8 dB means it is minus 8B is the height of the original echo, that is, A1. Okay, you have to find out. How much is this? You can find it in the way I have told above. Or this is actually required. This is also a solution. You can find it in this way also. It is the same, but it is written in a slightly different way. Nothing else. The actual echo height equals 90%. It will come here in 8 degrees. Okay, so you have got 90%. The value of a 2 is 90% and you have reduced it by 8 degrees. So in this way you will take antig 95% asterisk antig 8 slash 20. So the value of antig 8 slash 20 will be 2.51. So the actual echo height of the 1 was this 95 asterisk 2.51 equals 239%. Okay, so you can calculate echo in this way also. There is also an option available. Okay. So apart from this, if you want to remember it now, how do you have to remember it? Okay. Because it is 6 dB, then you know that the height of the echo gets doubled in it. Is that fixed? Okay. If you increase it by 6 dB, it will become 2 times. If you decrease it by 6 dB, there is another value like 2 dB, 4 dB, 12B, then what will be the height of the echo in that case? So see converting dB to echo ratio. dB can be converted to ratio echo without using calculator by remembering. So you don't have to use the calculator. You have to do it just by remembering. So if you increase it by 2 dB, then the height of the echo will become 1.25 times. Okay, if you increase it by 4 dB, it will become 1.6 times. If you increase it by 6 dB, it will become 2 times. It will become double. Will become if you increase it by 12 that is, like it is 20%. so it will become 80%. Similarly, if you increase it by 8 dB, it will become 8 times, and if you increase it by 20 dB, saw earlier that it will become 10 times. Then it will become 100%. If you increase it by 20 dB, then okay. So you can remember this ratio directly. Okay, like 1.6 for 4. You can do the calculation directly by using it. Even if you find any different value, for example, if you see in this, it is not 14 dB. Okay, 14 dB is not there anywhere in it, but you remember this. Then on its basis, you can also take the value of 14 dB. Only these 6 values, nothing else. If you remember only these 6 values, then even if any other dB comes, you can remember it easily. So, for 14 dB, okay, 14 dB means 6 dB plus 6 dB plus 2 dB. Simple, write 6 it like plus this. 6 plus 2 means 14 dB. So now for 6, you know what happens in 6. The height of your echo gets doubled. So asterisk 2 asterisk 2. Okay. What happens in 6 plus 6 and 2 dB? The height of the echo becomes 1.25 times. So now you have to multiply all these by 1.25. Right here you have done the summation of all three. But here multiply the value you get by 3. That means 2 asterisk 2 asterisk 1.25 will give you the answer of 5. So, when you increase 14 dB, the height of the echo will become 5 times. That means first if it is, then it will become 50%. Okay, so this is how it works. Similarly, is another example like 10 dB. If you do it in 10 dB, then 6 plus 4 becomes 10 dB. So, for 6 it is into 2. It will become 2 times, and for 4 it is into 1.6. Okay, so you have to do 2 asterisk 1.6. That means you have to do multiplication here. So if you increase it by 10 dB, then the height of the echo will become 3.2 times. Okay, so this is very. If you want, you can also take a screenshot of this in this thing. Will be very useful for you in the exam because time is less, especially for SAT Level 3 exam. So in the case time is less. So you know any of the rest is 9 dB or 11 dB. For this you can remember this and make such examples as per your convenience and calculate dB. You can do it. There is no need to do that long. There will be no need to use a calculator also. So this is how this dB calculation is done. You can do this calculation even without a calculator. So I hope you have understood this video. If you have any doubt in this, then you can ask me in the comment box. Okay, thank you.